Right. For number 1, you need to evaluate for G of 7 for G of 7. So put 7 in for all of your x's. And start simplifying. 7 squared would be 49. And when you multiply by 5 and then subtract 2, what answer do we get?
242.
942.
242.
243. So either of those could be your answers. G of x equals 243 or G of 7 equals 243. Questions on that one? For number 2, you need to graph this. So if you were getting this back in the slope-intercept form, so you go back. So our new equation would be y equals -3 over 2x minus 2. So we would start at our y-intercept of -2. Then we could go down 3 and to the right 2. Or we could go up 3 to the left 2 as many times as possible. And then draw our line. Make sure you have arrows. For number 3, we need to state the domain and the range of this graph. Here we have random order pairs, so this needs to be a list of numbers. What would our domain be?
-32.
So because these are random points, we have to have them all listed. So -3, if they were connected, then we could do it that way, but we would need to use our notation. For our range, what would that be? Lowest to highest. Lowest to highest. -1,
0, 2, and 3.
So if you have random order pairs, you have to list them all. But if they're connected, then you can say from -3 to 3, but you have to use your notation, or from -1 to 3, but using your notation. Questions on that one? Number 4, so this one, this is connected. So when we do our domain and range for this, it will be in the notation. So we need x and y and the line. Our domain is from what number to what number?
5 to
-5 to +4 and everything in between. So we need our notation. -5 is less than or equal to x, which is less than or equal to 4. What about our range? What would our range be? -5 is less than or equal to 5, which is less than or equal to 6. So if they are connected, we can use this format. If they are not connected, we need to list out each number. This last part, I'm not sure if you've seen something like this before, and I think somewhere along the year we'll get into this. But I'm going to explain it to you now. So these are comparing these two equations, f of x equals x, and g of x equals negative 1/2 x plus 2. When we are looking at these two, they're either comparing the slopes or they're comparing the y-intercepts. When they're talking about shifted up or shifted down, they're comparing the y-intercepts. So you're looking at this y-intercept, which is 0, and this y-intercept, which is 2. And you're looking at how do they differ. Is 2 higher or lower than 0? Higher. So this would be shifted up. For the second part, steeper or less steep, you're comparing your slopes. So the slope of this one is 1. The slope of this one is negative 1/2. Is negative 1/2, I was going to say lower or higher than 1. It's lower. So anytime it's lower, it's going to be less steep. You can think about it like this. You could actually graph this if you wanted to. F of x is going to be some line that looks like this. Directly through the middle, slope of 1. And then this one is going to look something like this. This is not accurate, but I'm going to try to make it accurate. Something like that. So with steepness, you could think about if you were like sledding or skiing or something down this hill and down this hill, which one would you go down faster? And the answer would be your f of x equals x. That would be steeper than g of x. So g of x would be less steep. Wow, I'm still using arrows. But in general, if the number is a fraction, it's going to be less steep. But if the number is not a fraction, then it would be steeper. Questions on those two? Right. Before we get into notes today, I wanted to make you guys aware of something that's going to happen next class. But I need to make sure everyone's paying attention. So make sure your laptops are closed and that you're paying attention. Okay. How many of you have heard in your English class about a STAR assessment? Okay, so if you haven't, you will be. So in English and in math, the county is doing this assessment where basically they're trying to get data of where everyone is. So on Friday, make sure that you bring your laptop if that's not something you normally do. We're going to be taking that test. You are going to be taking that test. In general, these questions tend to get harder the better you do. So as you keep doing well, the questions progress. So expect some of the questions to be difficult. It's okay if you don't know how to answer them. When you get to some questions that get really difficult and then you start getting them wrong, it will go back to a level that you would be more comfortable with. Okay.
Is there a time limit?
So there is a time limit per question, but not a general time limit, if that makes sense. So you have 3 minutes per question. Once that 3 minutes is over, like 15 seconds before that 3 minutes is over, I guess a timer will pop up to show you that you need to pick an answer. Otherwise, it will go away and it will count as a missed question. say.
Somebody said we had to take it in math and English like twice.
As two different things. So math is just math and English is just English. Yeah.
Said, because I have English first period, but I have to make it in English.
Say that one more time.
I'm not gonna be here Friday, and my English teacher, I have her first period. She said I'd have to make it in
I'm gonna say this, but pretend I didn't say this. I'm not doing that. Just because I don't have the class time to find who did and did not make that up. If you didn't make it up, it's just missed. But you didn't hear me say that. Go ahead, Aubrey.
How many questions in all?
I think they said it could be, it's supposed to be 34, but it could be 35 or 36.
For both?
I don't know about English. It could be 34.
It was 35.
Okay.
But is it affect their grades?
No. They're really using it for data to see how much you know, how much you don't know. And this is going to be something they're planning on doing it again towards the end of the year to see what you know now and how much you've grown since then.
I thought that was what the PSAT was for.
All of these things are for, yes, that purpose.
So it's technically
Yes and no, because it's not run by the same people. The questions could be different. The format could be different. It's computer, and well, ninth graders did take the PSAT on the computer, so I don't know what that looked like actually. Similar but different. Okay.
So what happens if we don't finish on Friday?
Technically, so this is something you're hearing me say, but I didn't actually say this. Technically, you should be able to finish within another day. We're not doing that. So it will just count as missed unless you come find me after school or before school and really want to finish it. Any other questions? Right. So yes, it is a test. Try to take it seriously, but really just do your best. Because there'll be things that you don't know, and that's okay. There'll be things that are super easy, and you're like, are you sure this is the right test? And it's okay. But just be prepared for that. I'll send out an announcement to make sure that you have your laptops on Friday, because that's when we'll be taking it. All right. If you think of any other questions, just let me know. We are starting a new unit. Your calendar is a little messed up because it doesn't have the STAR assessment on that. So there's that. So that throws your calendar days off, as well as sometime within the next couple of weeks, we're going to take an SOL pre-test to see what you do and don't know if you were to take the SOL like now. Obviously, there's a lot of things that we still haven't covered yet, so it's okay. But when we get ready to do that, that will be sometime in February as well. So the dates will be messed up again. I'll try and update Canvas once I know that date for sure. Great. Some of this may look familiar because I feel like you've done inequalities before. To what extent, I'm not 100%. But some of this will look familiar, some of it definitely won't. Just make sure you ask questions on anything you do not understand. So for this first part, you need to use an open circle. For less than or greater than, so that's strictly less than or strictly greater than symbols. And then a closed circle for less than or equal to or greater than or equal to symbols. Okay, so let's do a few. Let's say we solve an inequality and we got x is less than 3. Ignore the other numbers that are written here. Would that be open or closed? Open at 3. So you would draw an open circle at 3. And then going to the left or to the right?
It's going to the left.
Everything less than 3, so everything this way. What about number 3? If I had x is greater than or equal to 7, open or close?
Open.
Let me close. Close at 7. You can draw a circle, fill it in, and that would go to the left or to the right? To the right. Now, for the most part, whatever direction the inequality is pointing will be the direction you graph. I say most part because that's not always the case, because sometimes you'll end up where I have this, but it's flipped. So if I had something like 3 is greater than x, this is the same thing. They're just written 2 different ways. But I would not graph this to the right. I would need to read it backwards. If it's written backwards, I need to read it backwards. So x is still less than 3. Could you switch it around so you know which way? Yes.
So will that be on any test or quiz?
You may solve it and get an answer like that. Okay. When you're flipping it around, whatever direction the sign is pointing towards or away from the x, just make sure it's the same thing when it's flipped. Let's try some of these. For number 5, we see that that's an open circle, and it's going to the left. Which inequality symbol would that be?
You can choose.
Not both.
Greater than.
You had it the opposite way also. If I was reading it, x is something than negative 2. Would that be less than or greater than? Less than. But if I read it the other way, negative 2 is greater than x, yes, that would apply. Just make sure that you still know the other way as well. For 7, we know that's a closed circle at 0. What would your symbol be?
Less than or equal.
Less than or equal to. Questions on graphing or writing the inequality so far? Feel like that's something you may have done before. Right? This part may be something new. So here, you must flip or switch the inequality symbol when you multiply or divide by a negative number. So you must flip or switch the sign, the inequality symbol, when you multiply or divide by a negative number. So I'm going to give you a couple examples of what that would look like. So let's say I have something like negative 3x is greater than 3. And I'm trying to solve this, so I got to get x by itself. And I would divide both sides by negative 3. Well, when I do that, because I'm dividing by a negative, my sign is going to change directions. Magically, that happens every single time. Yes, Eric.
So the greater sign kind of turns into an equals.
Turns into a less than.
How we did it before. So like when we had the equation.
Oh, okay. Yes. Where the equation was for our equations, where the equal sign was for our equations, it's now an inequality symbol. But if you're dividing, it now changes direction. What would not change the direction is if I had something like this. 3x is greater than negative 3. Notice that the negative is now on the other side. So I'm still dividing by a positive, and my sign would not change. So if I am physically dividing by a negative, my sign changes. But if I am not, and there happens to be a negative, my sign does not change.
So it only changes when you're dividing by.
Yes, when what you're dividing by is actually negative. Right? Same thing with multiplying. This is rare, but it does happen. If you had something like something like this, where I need to get rid of 6, so I'm going to have to multiply on both sides by negative 6. That would be an example where I change my sign. But if it was similar to the other example I just did, where there's a negative on the other side, and I'm multiplying by just 6, that would not change the sign. So you actually have to multiply or divide by a negative number for the sign to change places. And remember to do that. Questions on that so far? Right, so with these, it's just like equations, solving the equations, except for there's inequalities. Pretend it is an equal sign, so that makes it easier to solve, but don't actually make it an equals, because you, what I've seen is that if you change it to an equals, you forget to change it back. You don't want to do that. Also, if we forget to change it back, you may miss changing the sign. So don't actually change it to an equal sign, but pretend it is one. That means we're going to solve this the same way. So how would I start solving number 9? Subtract on both sides. Remember what my next step is? Divide both sides by 3. Would my sign change?
No.
No. Once I have that inequality, I'm going to graph that. Here you don't have numbers given to you, so you can make up your own. That should be 2. Oh yeah. I was like, so many hands just went up. I did something wrong. You can make up your own numbers. I would say put this number like in the middle. You can put 0 in the middle too. That's fine. It doesn't matter as long as you have this number in there somewhere. And then, so I always start with this one and then just kind of go up and down. So up would be -1, 0, 1. Down would be -3, -4, -5. Does your number line have to match mine? No. Just make sure you have -2 somewhere in there. I said that. Would this be open or closed? Open at -2. Going to the left or to the right? To the left. Do you have any questions on how we solved that or got that answered? We're not going to do every single one of these together, because there are some that I want you to try. But we'll do 10 and then we'll start on the next week. Okay, how would I start solving number 10? subtract 2 on both sides, just like this one.
You get 6 multiplied times.
Multiply by 6 on both sides. We have x is greater than negative 18. Sometimes these numbers are kind of big. So we would put, or I would put negative 18 in the middle, and then kind of spread out from there. So going up, that would be negative 17, 16, and 15. Going down would be negative 19, negative 20, and negative 21. These are a little off. Be careful with your symbols. If this wasn't greater than or equal to, make sure you don't lose the equal to part of that. Or if it was just greater than, don't add the equal to part of that. So this would be an open circle going to the right. On to the next page. Now, in the past, when we talked about domain and range, we had that weird set builder notation where it was like x is, or negative 5 is less than or equal to x, which is less than or equal to 6, like what we were just doing in the short break. Now, we have interval notation, so it's going to be a little different. So it means the same thing. We're still talking domain and range when we do interval notation, or in this case, really just domain because we're looking at x's. But you have to relate it to what we were just talking about. If we use a parentheses, that means it's not included. It's an open circle. If we use brackets, square brackets, not curly, that would mean it's included, or it would be a closed circle. When we have like x is greater than 3, that means it starts at 3 and it keeps going all the way to positive infinity. Or the opposite way, if I had x is less than 3, it would start at 3 and it would go all the way to negative infinity. So here we're going to use infinity or negative infinity, and we need to use parentheses. Anytime it goes to one of those. Right? So let's start with number 1. How would we start solving this? Distribute, yes. You could also, in this case, divide both sides by 4 since 24 is divisible by 4. Either way would work, but you could distribute. So 4x plus 12 is greater than negative 24. And then what?
We did
Subtract 12 on both sides. So we have 4x is greater than negative 36.
nice.
And when we divide, would our sign change?
No.
So that would be our inequality. X is greater than negative 9. So I could start here, negative 9, negative 8, negative 7, negative 6, negative 10, negative 11, negative 12. This would be open or closed. Open at 9, going right or left? Not left, but right. And then for your interval notations, we need to look at where does this start and where does this stop, kind of like domain and range, but left and right. So where does this start? At negative 9. This is not included, so we're going to use a parenthesis, negative 9. Where does this end? Positive infinity. We're going to draw our infinity. Infinities always have parentheses, and that would be our interval notation. So that would be the same thing as me writing this. These two things are the same, but we need to be able to write them. Okay.
If it was a negative, would there just be a negative sign or be a sign?
Yes, and negative infinity would come first.
Okay. Okay, so
it's always left to right, yes.
Is it negative 50 comes first?
Because if it was less than, where it would start would be negative infinity. I don't remember which ones exactly give you that. Let's do another. Let's do number 4. What would we do first? Distribute the negative 8. We have negative 8x plus 8 minus x is less than or equal to negative 8. Then what?
You subtract 8.
You could do that. You could also combine your like terms. So either or, that order doesn't matter. So let's say we combine our like terms first and then subtract, but you could subtract and then combine, doesn't matter. So here we have negative 9x plus 8, and then we would subtract. And then divide. When we divide, is our sign going to change?
Yeah.
Yes, because you're negative.
So I tried to choose one that had a less than, but we ended up changing the sign. So it didn't work. So 4, 5, 6, 7, and 3, 2, 1. Close or open? Close at 4. Going to the right. For our interval notation, where do we start?
4.
4. But this is closed, so here we would need a square bracket with 4. Where does this end? Positive. Positive infinity. Questions so far? Let's see. I'm gonna put this in real fast and see if I get one that's negative. That one would work. So let's do number 5 on the next page. And then we'll do maybe a couple more. For this one, we have choices. What do you want to move first?
1.
The 1. So we would subtract 1 on both sides. Your 6x is less than negative, sorry, number, 8 minus 2x. So we would then need to move our 2x over to the left by adding. So we have 8x is less than 8. And then divide. Here our sign would not change because we didn't divide by negative. We have x is less than 1, so there's a 1 in the middle. It would look something like this. That should be 0. This would be an open circle going to the left. Now for this one, where does this start? Negative infinity. So it'd be parentheses, negative infinity, and where does this stop? Or end? 1. And 1, yeah, this one. This is not included, so that would also be parentheses. Because it keeps going all the way to the left. Just like when it goes all the way to the right, it ends at positive infinity. Because it goes to the left, that's where it has to start. This is opposite of what the positive infinity is.
So when the infinity is going to the left, then it's negative infinity first.
If it's going to the left, then negative infinity comes first. Yes.
That's good.
You have other questions on how to solve this one? So, go ahead. number 10. What would we do first? Distribute but twice on both sides. Now, here we are multiplying by negative. We're not changing the sign here because we're not doing it to both sides. So this would just be negative 3x minus 3 minus 2x. Our sign would stay the same. Minus 4x plus 8 minus 2. So only when you multiply on both sides does your sign change direction. Combine your like terms, so we have negative 5x minus 3 is greater than negative 4x plus 6. Then we have choices. What do we want to move? Okay. If we move 3, we would be adding negative 5x is greater than negative 4x plus 9. Add 4x to both sides to get negative x is greater than 9. Divide both sides by a negative. So here, would our sign change?
No.
Yes. So our number line will look something like this. With an open circle going to the left. And what would our interval notation be? Negative infinity to negative 9. Parenthesis or bracket? Okay. Do we want to do one more together, or do we feel like we got this? Okay. I do want to show you two things really quickly. Let's say we're back at this step, and instead of moving our number first, we move one of our variables. So I added, let's say I did it this way. So that my variable is now on the right instead of the left. These two things are the same thing, but if in your mind you don't like it that way, you can switch it. Whatever direction it's pointing to or from the x, make it the same way. So right now it's pointing towards the x, so it needs to point towards the x. Yeah, as long as you read it backwards. X is less than negative 9. If you read it this way, negative 9 is greater than x, you may graph it as greater than instead. So just be careful with that. Right? So that was one thing I wanted to show you. The last thing, this would be like a really good check method. There are two, really. One is algebraically, because we know this is x is greater than negative 9, pick any number that is less than negative 9. So negative 10, negative 20, sure, whatever number you want. If you were to put that number in, you could see, does that work? Another thing you could do is put this entire thing into decimals. So let's say I did that. I'm going to put my equation in for number 10. we have negative 3x plus 3. I forgot 3. Minus 2x is greater than negative 4x, not x. X minus 2 minus 2. It's going to graph this for you. That's not what I'm meant to do. And it's going to show you a horizontal line or a vertical line to show you that's where your answer would be. You could click on where it crosses the x-axis to show you what that number would be, and it'll show you whether it's below or above or shaded to the left or shaded to the right. So it's a really good check method when you're using Desmos. Yes, yeah.
You said to put any number in. You put the number in for all the x's.
Yeah. But one side at a time.
So like, I'll be putting negative 12 on one side.
Because it should work actually. You could do it all together. It should still work out that like you'll get, like in this case, something greater than the other. It'll be two different numbers. Unless it's equal to, then you might get the same number. Where you can see it's a true statement. Say, did you have a question? No. Do we have any other questions about this? Alright, I'm going to give you the next 10 to 15 minutes and I want you to go through as many of the problems we didn't just do and work through those. And then when we come back and we go through these answers, we're going to start on the very last page. Starting with number 2, so I'll say the inequality talks about the direction, whether it's open or closed, and then the interval notation. So for number 2, you should have gotten x is less than negative 5, so that would be an open circle to the left. Your interval notation would be negative infinity to negative 5, both with parentheses. Number 3, x is less than or equal to negative 2. That would be a closed circle going to the left. And your interval notation would be negative infinity to negative 2. The negative 2 would be with a bracket. Questions on either of those two? Carrie, you can go. On the next page, number 6, x is greater than or equal to negative 7. So that was a closed circle going to the right. Then your interval notation would be negative 7 with a square bracket and then infinity.
Are they supposed to both be brackets?
No. Anytime you go to infinity or negative infinity, that's always a parenthesis. For 7, x is less than or equal to 6. So that was a closed circle to the left. So negative infinity to 6 with a square bracket around negative 6. I'm sorry, 6. Number 8 was x was greater than negative 3. So that's an open circle to the right. So there'd be negative 3 to infinity, both with parentheses. 9 was x is greater than or equal to 11. So a closed circle to the right. And that would be a square bracket with 11 going to infinity. Do we have any questions on any of these? With the last little bit of time we have, we're going to jump to the word problems. 5 we did together, but here's 6. So find the page that looks like this. I'm going to have you guys fill in the chart. So anytime you see these words, you should be thinking these symbols. And I'm going to draw the symbols as well. For at least, that would be greater than or equal to, because you can have at least $500, but you could have more than that. At most is less than or equal to. That's something you can't go past. I have at most 2 legs. I can't have more than 2 legs. No more than would be less than or equal to. So same thing as at most. I have no more than 2 arms. That means I have 2 arms. I could have less, but I don't have more. More than is the same thing as greater than. No less than is like the opposite. So less than would be less than, but no less than is opposite. So that's greater than or equal to. And then less than is less than. So here when we see less than, it's not subtracting. Unless it's in there twice. Sometimes they do that, but very rarely do they do that. So with these, we're going to define variables, set up our inequality, and then solve. We'll do a couple of these together, and then I'll let you try a few. Anyone still need this? Okay, let's do this first one. I'll read it out loud. So Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? So important things. What do we find that's important? $500 in the savings account at the beginning of the summer. He wants to have at least $200.
Withdraws 25 per week. And then has 2 weeks.
So what we don't know is going to be our variable. How many weeks? So we can say W equals number of weeks. And we need to set up this inequality. First, what is our inequality word that we recognize? At least, and which inequality would that be? Greater than or equal to. So we know that much. Now, which of these numbers? That's not the question I want to ask. Withdrawals. What operation would that be? Subtraction. So we know we're going to be subtracting 25. But from what?
500.
Yeah. So we don't know how many weeks the 25 and the W are going to go together.
So, like, you do 500 W minus 25.
In this case, we do 500, yeah, which is it? 500 minus 25W is greater than or equal to 200. So we're starting off with 500, we're subtracting 25 per week. We don't know how many weeks. At the end of the summer, we want to have at least $200, could have more, could have less. But this part needs to be either greater than this or that.
Or can't we just divide 300 by 25?
That's what we're going to end up doing, kind of, but you would still need to set up your equation. What would that number be?
12. And once you change the sign,
Yes. That means for 12 weeks he could withdraw money. If he were to withdraw more than 12, he would have less money than what he wants. So we cannot go past 12. We could do less than 12, but we could not go past 12. Because this is a word problem, we also would need units. So 12 would be the number of weeks he can withdraw money from.
it's a we have to write it.
And I would say no more than 12 weeks. Even though we started off with a at least, which was greater than, we changed it to a less than or equal to, so no more than, or the other word I said at most 12 weeks. Because he can't withdraw money 13 weeks. He'd have less money than what he wants. Any questions on that? We're going to do one more. Number 3 on the back. So Chris wants to subscribe to a meal subscription service. Each meal costs $15.99 plus a one-time shipping cost of $9.99. If he can spend no more than $100, how many meals can he buy? So important things. We have each meal costs $15.99. Look for those words, each, per. Those are going to be your multiplying things.
One-time shipping costs $9.99.
What's the one-time shipping cost?
That's
No more than $100. And we're looking for meals he can buy. So number of meals he can buy would be our variable. We call it M. No more than, which symbol would that be? Less than or equal to. You know, no more than 100. How would we write the rest?
3.9 plus 9.95
Because in this case, each meal and number of meals, those two things are going to go together. So we have 15.99 M plus 9.9. Sometimes it will give you words like plus as in addition to. Sometimes it won't. Right? And then to solve this. give us what?
Like 90, 90.01.
And divide. What do we get?
We rounded it to
What was it exactly?
like 5.69.
5.69. And then in this case, because we're looking for number of meals, we would need to have a whole number, and you would need to decide, could we round up to 6 or would we have to round down to 5? Eric, you said 5. Why 5?
Because you can't divide 0.69 a million.
True, but why wouldn't we round up to 6?
Because that would exceed the $90.01.
So if we round this up to 6, then if we were to put 6 back in, it would go over the $100 that he has. So we can't spend more money than we have. So we could round it down, and then we'd have a little bit of extra money at the end. That's okay. So no more than 5 meals. You have 3 more problems. 3 more problems. In the next 5 minutes, I want you to try those, and then I'll let you grab your phones. Yes. Are you finished with them already? Yes. The answer to number 2 was no more than 12.7 or 12.69 miles. Number 4 was at least 950 bags. And then number 5 was less than 40 degrees. Okay, so if you didn't get those answers, make sure you try them. Again, make sure you bring your laptop for Friday. And then if you